In this video, I wanted to discuss some applications of all of the trigonometry that we've been talking about with regards to SOHCAHTOA. Um, and basically, let's say that we are trying to figure out, say for example, you're looking at a building and you want to know how tall is this building, or a problem that could be very difficult, like for example, a redwood tree. You want to know the height of the redwood tree, but you don't want to climb it with a ruler, right? It's a problem where how could we figure out such things? But you can actually use trigonometry to find these things if you know, for example, what we call the angle of elevation or the angle of depression. So when you're talking about these sorts of angles, typically the angle that you're referencing is with respect to the horizon. So say, for example, we're looking at a word problem like the one in the packet, which says that a giant redwood tree has a shadow. Sorry, I did not put that up correctly. A giant redwood tree has a shadow which is 532 feet long. It says find the height of the tree if the angle of elevation is 25.7 degrees. So that's a typo. Should say if the angle of elevation is 25.7 degrees. But like what we could do is we could imagine in this situation, imagine that there is a right triangle going on. So we have our redwood tree. And I'd always recommend if you're working on a word problem, try to draw it if you're not really sure, where to begin. So this is my very artistic redwood tree. I'll go ahead and, put a little color in here. And I guess I'll make the tree stump red since this is a redwood, right? Because of course a redwood tree has a very, very bright red bark. All right, anyways, so we have our tree, and we want to know how tall it is. But what we're given is that it casts a shadow, and I guess I'll do the shadow in black using my tremendous art talent. It casts a shadow with length 532 feet long. And notice that, say I was trying to find the height of a redwood tree, it'd be very annoying to try to climb that tree and, bring a tape measure up it. Very difficult to do that. But if I'm on the ground, it's much easier to figure out how long its shadow is because it's the ground, right? I don't have to climb any trees to get that measurement. But anyways, so that's one thing, it would be easier to measure. But also something that we could measure with a protractor or other, not a protractor, but there's various devices which can measure angle of elevation. Let's say I figured the angle of elevation to be 25.7 degrees. But anyways, what that term is, the question is, well, which angle is it talking about? Like typically the angle you're going to be given is with respect to the horizon. When it's the angle of elevation, it's kind of like, well, how tall is it from the flat? It's not going to be this angle up here. That's my point, is it should be the angle down here that you're given. Because it's not going to be specific necessarily to which angle. So you have to figure it out. But usually that's going to be the context of theta. But anyways, notice that if I was to translate this into a geometric figure, I see that I have a triangle with some things that I know. I know that the base of that triangle is 532, and the angle theta here is 25.7 degrees. And also another assumption that you're going to have to make in these questions is that it is a right triangle, because most trees, they grow straight up because they are trying to get as much sunlight as possible. Now, this is something that's not always true. So this problem is technically not worded clearly enough, but it's an assumption we're usually going to make. And if you're wondering, what about the case when the tree is not flat? Well, it would specify, okay, this tree is growing sideways or at a particular angle. And we wouldn't be able to solve it with SOHCAHTOA if it wasn't right, so this is just an assumption we have to make. But I know for those of you who are like, okay, it doesn't really say that, sometimes you got to read between the lines. Anyways, but notice what I have is two knowns and a right angle. This is enough to solve the triangle. I know one side and one angle. I obviously could solve the third angle on the top via because they're complementary. So that would be what, 54.3 degrees? No, 64.3 degrees, since they have to add up to 90. Or just take 90 and subtract away this one. And I could, of course, solve for what I really want to know is the height of the tree. So if my question was, well, which trig function should I use? Should I use cosine, sine, or tangent? I would choose to use tangent here because I know the shadow length, which is adjacent to the angle, and what I want to find is, well, what's the opposite side? Like it's technically not even asking me for the hypotenuse, so I could just completely skip that and just use tangent. So, excuse me, tangent of 25.7 degrees is equal to opposite over adjacent. And my point is I know everything that I need to except for the opposite side. So if I multiply across by 532, I would have that the height of the tree, which is the same as the opposite side, must be equal to the shadow length times the tangent of the angle. And this will always be true for such questions where you have the length of the shadow and the angle to that the shadow is created from the sun. Um, and also another thing about this is like you can kind of imagine the sun's up here in the sky, like the angle at which the shadows, the length of that shadow is going to change as the day grows. But what will not change is this angle of elevation. And you could solve this, um, you know, well, there's various instruments for figuring out the angle of elevation, but it's a way that I could figure out the height of the tree without actually, needing to climb the tree. And this is one method that a lot of people will use to figure out, well, what's the height of something very tall and very difficult to measure? Is just by using some very basic trigonometry. And actually, also, if you know the time of day, you don't even need to solve the angle. There's another way of figuring out the angle which the shadow would form, just by using your position on the Earth and time of day. But that's way more complicated. Anyways, we could then use a calculator to figure out the height of the tree. So 532 times the tangent of 25.7, and that would give me 256 approximately. And again, that would be in feet because it's going to keep the same units as the original. And that would, again, tell me approximately the height of the thing I'm trying to figure out. And of course, we could apply similar logic to, let's say I wanted to know how long the hypotenuse was if I knew the height of the tree. Or let's say if I knew how long the hypotenuse was, if I know one angle and one side, it's enough to find the rest of the information about the triangle.